Good afternoon.
Good afternoon.
Thank you. So, what I want to talk about this afternoon is, of course, VANTIQ and our technology. But I want to base it on something that is much deeper and much more important. There is a transition going on in the world that has only two similar situations I can recall. One was when computers were invented and started to be deployed about 70 years ago. The second one was the internet, techie term, and the third one now has a very technical term too, but I want to broaden it and explain why. It's called event-driven architecture. Maybe we can improve upon that term. So let me move through and I'll introduce it as I go through this presentation, this discontinuity I'm talking about. So first, about VANTIQ. So our mission as a company is to enable organizations to use modern technologies, IoT, AI, etc., to use them to experiment, to innovate, to change the way things operate. And to do this, we introduced a platform for developing these modern apps, which, as I said, are event-driven, and to deploy them and manage them. In order to succeed in addressing the market we're talking about, I have built one of the most powerful executive management teams ever. Each of us has been in about 5 software companies, and many of them were sold for $1 billion or more. So now let's talk about these changes I mentioned. Well, the first change started perhaps 70 years ago when companies started to automate themselves. They created databases, they entered orders into the database, charged companies, and basically took what was done by hand in the back office and automated those processes. And then, of course, the internet came into being about 25 years ago. And what the internet enabled was real-time systems, but still with the same architecture. If you look at Amazon, if you look at Netflix, yes, they access your smartphone and they do innovative things business-wise, but the architecture basically remains the same, this 3-tier architecture, server, database, and front ends, although sophisticated ones. And then they introduced some amount of AI on the surface. Now we look at the environments today using AI, using IoT, mobility, Internet of Vehicles, etc. And we moved into a whole new set of complexity. We're all familiar with this. We almost take for granted AI, we take for granted there are going to be autonomous vehicles, etc. Those are the capabilities that are being introduced into the market. But there's one other phenomenon, a very important phenomenon. The behavior of these systems is going to be totally different. It's going to be based on real-time events as they occur. Now, interesting, if you think about this, this is how the world operates. You operate on events, not on databases. Everything in this conference, walking around, talking to people, having lunch, going somewhere, being directed, everything is event-driven. That's not how these systems work that most corporations build for their AR, for their back office systems, for their supply chain management. Those systems have some amount of events that occur, but primarily they're automating how businesses function. Now this results in a different architecture. For the last 10, 12 years, when we talk about the cloud, everything goes to the cloud. Now we're going to see a huge switch. We're going to see edge processing. We're going to see processing outside of the cloud that is going to be orders of magnitude bigger than the processing on the cloud. And why? That's because the events occur there. And where we are moving to today, to give some concrete examples, are possibly a lot of events coming in, IoT sensors, cameras for image recognition, analyzed on the edge because of latency and the volume of data. You've got to analyze these events where they occur. Then the information can be passed to a cloud or an on-premise system to do further analysis and possibly at this point store the information in a database for later use. And as a consequence of this, actions can be taken by either people or systems automatically. Now, edge computing, we're starting to say it has its purposes. The argument I'm going to propose is it doesn't just have its purposes, it is the future. And these sensors that we're talking about today, if we go out 10 or 15 years, for security reasons, among others, they're going to be intelligent too, even if they only cost a quarter, and actually encrypt the data at that location. But that's a little futuristic. Let's talk about today. And today where we are is this type of architecture. And more it's occurring where things will be analyzed where they occur. An example is Internet of Vehicles, autonomous vehicles on highways, on streets. You cannot send that to the cloud, obviously. It's got to be processed where it occurs. And some of the use cases I'll be talking about will give further examples of that local processing requirement. Gartner Group recognizes this transition, and as they say here, the majority of business organizations will participate in event-driven digital business ecosystems. This is the beginning of this major change that's occurring. So the way these previous systems work basically was there was some database, and then there were inputs into the database and outputs from the database, and this was the architecture. Now if we look at the architectures that we'll be using in the near future for the majority of software, it's going to inherently include what are called event brokers or advanced event brokers, which will take events from anywhere, analyze them where they occur to some degree or to a big degree, move them over to systems of interest, do further analysis, and take further action. The bottom line is this is what's called event broker technology, and these systems are going to require this. So let's look at some of the real-world situations. Now, I'll give you a real-world situation. If you walk up to a hot stove and you touch that stove, you're going to immediately remove your finger. That doesn't go to the database in the brain. It doesn't go to a database that says, that looks like a stove, steam's coming up, it's probably hot, and I shouldn't touch it. It's automatic, kind of similar to edge processing, that you touch it and remove your finger. Then later on, the brain stores in its database, in its memory, the fact that anything that has smoke rising from it, looks like a stove, etc., probably can burn me. And that's how the system works. So it's first the reaction, then the system actually stores information. This is really a form of AI. Maybe it's simple algorithms, but where does it run? Where do those algorithms run? They run at the local processing location, on the edge, and in the cloud. So we're going to have AI distributed everywhere in the future. In addition, we want to be able to reuse the information that occurs. So when you know about being burnt, you want to reuse that later on. These types of events can be stored. Let me give you a practical example. Let's say you had a camera in here that identified who was invited to this event and who's sitting there, who's not. Well, you could store that information and use it for a lot of different applications. You could use it for the security personnel here, for charging, etc. So events plus logic associated with it can be stored and reused. So to meet this high-level reusability, VANTIQ created a catalog. In the catalog, events are stored with associated logic, which create what we call derived events. And they can be used by many different applications. Let me give you a practical example. Let's say a car pulls up to a meter anywhere, and the meter has the capability of taking a picture, an image of the license plate. That event, having that license plate at a particular location, at a particular point in time, can be used by lots of different applications. It could be used by the charging application, charge this car for parking. It could be used by a security application. It's a car owned by a known criminal. It could be used by an emergency application. All vehicles are supposed to be removed today because there's flooding in that area. And you could go on and think of many different applications that could use that same data. By having this type of architecture, for those of you who are technical, it's probably most of the room, you're actually decoupling what's happening in the real world, the events, from the logic associated with it. And what that enables is true agility. Components can be added one after another for any particular event or derived event. In fact, this requirement is going to be so great in the pretty near future, We will not be the only company having an event catalog. We're the first, but we expect others to copy that type of technology because it is so obvious when you're building, the need for it is so obvious when you're building these real-time systems. Although I will say we have about a 4-year head start, so we're pretty comfortable. And one of the other key reasons for this event processing on the edge, performance. It's the only way systems are going to scale or even work. Again, think of Internet of Vehicles. As cars are moving around, even with 5G networks, you've got to process the information where the vehicles are at any point in time. Then how do you build these applications? Well, let's say we have an Uber, a need for an Uber or a DD application. Wouldn't it be nice if that application could be visually painted? With the events coming in, actions taken on the events, for example, locate a vehicle of this type within this distance. Track the vehicle to pick up the customer as it moves around using GPS. So this type of agile programming environment, which VANTIQ has, is a key requirement of building these systems because they're going to be so much more complex. Now there's another result of this complexity that's going to occur, and that is that humans need to be involved at the right time. So let's use the example of a jet plane. Most of it's automated. 99.5% of the time, the pilot has almost nothing to do, communicate a little bit. But when things go wrong, the pilot needs to be involved. Now, I'm going to talk about something a little controversial, perhaps. Unfortunately, it's based on something very sad that happened. 2 Boeing plane crashes. And what's happened is, and I've heard this in the news, so have you, they keep on saying something in the system was wrong. The software was wrong. Maybe there wasn't 2 sensors of a certain type. And I'm going to argue that's not the primary problem. So what is the primary problem? Primary problem exists because software can never be 100% reliable. We all know that. We're in the industry. There are going to be bugs, no matter how much QA you put into it. You can't test for every permutation. What's needed instead is some kind of an event-driven architecture. So why an event-driven architecture? Because it forces you to think a little bit differently. So let me give you 2 examples of types of events that could have occurred that could potentially prevent these types of disasters. 1, the system notices that the pilot is doing something different. He's pushing on the yoke really hard. The force is stronger than ever. And therefore, the system should generate an event to the pilot. Hey, we see you're fighting us, or fighting me, the software. Do you want to stop? Do you want to interrupt or give him some choices? Or the opposite. The pilot notices that the system isn't working properly and can create an event to the system. Now, you could argue if you're a programmer, well, I could program all that. Good luck. That is very complex spaghetti code you're going to be creating. Whereas if you have an event-driven, natural event-driven system, you could plan for this ahead and change it when requirements change. So, in summary regarding human-machine collaboration, it is going to be a big part of these systems because the systems we're creating are too complex. That was the message I'm making. And when you talk about smart cities, which monitor so many different facilities that can interfere with each other, you need to be able to give the ability for humans to be in charge. And so to talk about VANTIQ, when we developed the product, the first thing we did was build an event broker. The second thing we did, even though our history was building 4 application development platforms before at different companies, the second thing we did was layer an application development deployment capability on top of the event broker. And at this point, we're unique in the market by combining those 2 kind of different sets of technology and enabling the applications to be built that exist in both of those sets of technology in a very agile way, primarily visually. So I'm going to go through a few examples very quickly at a high level to just give you some feel for the types of applications that are enabled in VANTIQ. First one is a smart airport. This is Capital Airport in Beijing, 7,000 cameras, 1,000 servers running AI at the edge, analyzing for problems, people running, people falling, and then notifying the closest security personnel and the security office. And even though the architecture for a system like this is complex, the blue shows all the places that VANTIQ is generating code, The development of these applications can typically be done by a couple of people in a few weeks because we hide the complexities. Here's another application to show the scalability of the system. This application will monitor 250,000 elevators in Shanghai, all of the elevators. It'll monitor them for failures, for safety, using image recognition to identify if there's a criminal on the elevator, etc. Here's a consumer usage application, flooding in Belgium, that monitors through IoT sensors the status of the levels of the rivers and streams and the land, warns people, combines it with weather information, and gives them guidance to a safety shelter if needed, or goes and picks up the people. This can save lives. What I want to talk about next is a relationship we just put together with SoftBank. SoftBank identified VANTIQ as having advanced technology. And so there are three parts to this relationship. First part, we're working with SoftBank to enhance the technology, both ours and theirs, to make it address market needs better than anything else out there. Second is, SoftBank will be reselling both the VANTIQ environment and applications built in VANTIQ. And third is, SoftBank has taken an investment and as lead investor in the Series B, and Talmasan, who's in charge of IoT and AI at SoftBank, will be on the board of VANTIQ. The first set of applications that we'll be building together are smart city applications to address security, safety, etc. The competition we see in the market is typically companies that attempt to put multiple products together and versus VANTIQ, which is a single product and far easier. We have a number of other partners in Japan, as listed here, and for time I won't go into it. We also started a consortium called the Eventdriven Architecture Consortium, where there'll be future events here where you can learn more about event-driven approaches. So in summary, we think we're introducing very unique technology into the market. The use cases I shared with you, are also very unique, and we've had excellent product reception so far. With that, I thank you very much.